Today, we'll be looking at independent sample t-test. Independent sample t-test is an inferential descriptive statistical tool used to determine the level of significant difference between two or more categorical data like gender, qualification, age, and experience. If you compute your data using your SPSS and then you analyze for independent sample t-test, popularly called t-test, there will be two tables that will appear in your SPSS output. The first table is the table that tells you about the mean difference between the two data, while the other table is the major table here. It is this table that you will look at to determine the level of significant, the difference, whether there is a difference or there is no difference. Remember, you are testing your hypothesis at 95% confidence level or 0.05 level of significant difference. It therefore means that this table here will be very, very important to be able to determine the next step to go. So this particular column is very important, and this other column. The SIG column and the two-third column are the two columns that you will look at to determine whether there is a difference or there is no difference. If this value here is above 0.05 level of significant difference, that means you have to go to this value here, the first value here under the two-third column, the first value here. Then weigh this value with 0.05 to know if this value is above 0.05 or is less than or equal to. If this value here is above 0.05 level of significant difference, it means there is no difference. If this value is above, it means there is no difference. But if this value here is equal to 0.05 or less than 0.05, it means there is a difference. So if you postulate a null hypothesis, for instance, this value already is above 0.05, we'll go to this value here, and this value here is also above 0.05. It means we have to accept the hypothesis that there is no significant difference. So if this value is above 0.05, you conclude by saying there is no significant difference. It therefore means that the hypothesis is accepted if it is the null form. Remember, you are testing against 0.05. So in both, whether you're using this value are all weighed with 0.05. So the understanding is that you will use this value here to weigh this and this. So you are testing your hypothesis at 0.05 level of significant difference. First step you must consider is to look at this column. If this value is above this value here is your cutoff p-value. The same function 2.50 does in 4-point Likert scale mean. It's the same function 0.05 does here. So this is the decision p-value, the cutoff p-value, to determine whether you will accept or reject a null hypothesis. So if this is your p-value, it is the cutoff what? P-value. If you are testing at 0.05 level of significant difference. So the first step you must consider is to look at this value. If this value is above this value, you use this value, the first value here under the two-third column. But if this is below or equal to, you use this value. Then when you come to any other value, weigh this value with same 0.05. If this is above, you will not accept the hypothesis. But if this is below, you do what? You reject. If it is below or equal to, you reject the hypothesis. So from here now, it could be written this way, that P is greater than 0.05. P is what? Greater than 0.05. Our P here is what? Is what? 0.847. These are P. This is our P. Our treated P value here is 0.847, which is the P above 0.05. So at this point, you do what? You will accept the hypothesis. For instance, if we postulate such hypothesis like there is no significant difference between the mean ratings of male and female students on the impact of truancy on their academic performances, and we have analyzed our data using our SPSS, this is our output. It means that so long as this value is above this value, I will now look at this value, and because this value is also above this value, I will now conclude by saying that the to-date value of 0.47 is above 0.05 level of significance, and as such, the null hypothesis is therefore accepted, which confirms that there is no significant difference between the mean ratings of male and female students on the impact of truancy in the academic performances. Please do well to like the video, share the video, subscribe, and comment. Thank you.